Good evening. Welcome to the QCIS channel. We're on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight I'm going to talk about an interesting subject. And that's because I saw a movie today, Jurassic World. And if we look at how movies, buildings, manufacturing are produced, there are two words that I can tell you that produces those topics that deal with images, taking photos to make them look real. That's computer graphics. So tonight, we'll talk about what's in computer graphics. What's in computer graphics? Now, let me go ahead and share my screen. And tonight, we're going to talk about, again, computer graphics, hypermedia, and multimedia. And then to break it down, the topics we're going to focus on computer graphics, dynamic media, beyond the printed page, interactive media, eye, ear, hand, and mind, data compression, how and why. And then here's a quote from Doug Engelbart. If you look out in the future, you can see how best to make right choices. If you look out in the future, you can see how best to make right choices. Now, when we focus on computer graphics, we have to find out what's included in computer graphics. Well, I'm going to tell you, there's painting software, digital image processing, drawing software, 3D modeling software, CAD, CAM, and there's also presentation graphics. Now, when we get into the painting software, what you see on the screen are pixels that represent paint. So basically, the paint pixels on the screen with a pointing device such as a mouse, joystick, trackball, touchpad, or pen. The pointer movements are translated into lines and patterns on the screen. Graphics talk. So we first mentioned pixels, which pixels are tiny dots of white, black, or color that make up images on the screen. And then we move to the palette of tools that mimic real world painting tools and other tools unique to computers. Now, one aspect that you may have seen if you're working with any type of prototypes or architectural drawings, you're looking at rendering and you're looking at raster. Raster is also in GIS for map making. Well, we have bitmap graphics or raster graphics, and they're basically pictures that show how the pixels are mapped on the screen. And then color depth is the number of bits devoted to each pixel. And of course, resolution is the density of the pixels. Now, if you're going to upload some computer graphics software, particularly some CAD, it's best that you utilize a workstation, one that has 32 to 64 gigabytes of RAM because of the size of the file that you are uploading to your computer. And a workstation, and I'm doing this video on what we call a ZBook. It's a workstation from HP. It was 8. I had it upgraded to 32, and I can also do CAD. It's a workhorse. It's much better than a regular desktop computer, which you're going to get 8 GB for the most part. Now, as I move on, we have digital image processing. Digital image processing, or we call it photographic editing by computer, like you take a picture and you can crop it. Well, when it comes to digital image processing, you have software that allows the user to manipulate photographs and other high resolution images with tools such as Adobe Photoshop. Again, there's software that allows the user to manipulate photographs and other high resolution images through tools such as Adobe Photoshop. Far more powerful than traditional photo retouching techniques, can distort and combine photos as demonstrated in the tabloids, can create fabricated images that show no evidence of tampering. Building a photo collage, take an image, combine it with objects, make a statement. See this image here on page 7 or slide 7 of my PowerPoint presentation. Regular image, combine it with a couple of objects, and then they added some other features, clouds and water. Drawing. But you have object-oriented graphics. Drawing software basically stores a picture as a collection of lines and shapes. It's called object-oriented or vector graphics. Memory demands on storage not as high as bitmap images. Any drawing tools, line, shape, and text tools are similar to painting tools in bitmap programs. Pixels versus objects. Now, look at this object. You have 2 glasses. One's a regular drinking glass, you have a lamp, a wine glass, and you have markers, and you also have a hardwood table. Well, in bitmap painting, the pixels give you these advantages: more control over textures, shading, and fine detail. Appropriate for screen displays, simulating natural paint media, and embellishing photographs. If you look at my background, that's computer graphics. But look how the shapes, you look how the shading, you look at this picture, although it has some animation, it looks very real. And that's because of the painting. Object-oriented drawing. We're still under pixels versus objects. Gives you these advantages. Better for creating printed graphs, charts, and illustrations. Lines are cleaner and shapes are smoother. Now, you can have some professional resumes. You can have professional reports, all done with object-oriented drawing. You look at this picture. Now remember, you have to be careful when it comes to creating smart art. Rules of thumb. You need to choose the right tool for the job. Don't be afraid to experiment and create your own chart. Use computer clip art images that are either in the public domain or available through licensing. Don't borrow without permission. And if you utilize your own work or even hire somebody to do the work for you, make sure you buy the copyright from the person that you hire to do the work for you, because they're going to claim it as their work. But if you, again, do it on your own, copyright your art. Copyright C inscribed in a circle, and the copyright lasts between 70 and 75 years. Come to my favorite, 3D modeling software used to create three-dimensional objects with tools similar to those in drawing software. Goal for some applications is basically to create an animated presentation on a computer screen or videotape. It's also flexible. Why? Because it can create a 3D model, rotate it, view it from different angles, and walk through a 3D environment that exists only in the computer's memory. Under 3D modeling software, images in the wireframe view, here in this PowerPoint, ones on the right are fully rendered to add surface texture. So what they did, they took a 3D drawing of a computer, they rendered it to make it look very real. Now you see this with Fusion 360, Inventor, 3D for making movies. But now in my field, there's a program called Civil 3D that does it. Chief Architect does it. You also have Revit for building information modeling that does images like these. Of course, they're in different industries, but the concept is still the same. CAD, CAM, turning pictures into projects, which the projects are products. Turning pictures into projects, which are products. Now, computer-aided design, software that allows engineers, designers, and architects to create designs on screen for products ranging from computer chips to public buildings. You can use CAD and CAM to test product prototypes. It's much cheaper, faster, and more accurate than traditional design by hand techniques. Now, again, when I started drawing, we were doing everything by hand. Now, the problem with doing everything by hand, you have to do a lot of erasing, and your lettering had to be good. But with CAD, you don't have to do that. It's much easier to go in and edit everything. And you come out with a clean drawing, very presentable. Now, there's also computer-aided manufacturing, still in CAD and CAM. Well, what computer-aided manufacturing does, it's basically a process. What it is, computer-aided manufacturing is a process by which data related to the product design is fed into a program that controls the manufacturing of parts. Like I could have data if I want to make a widget, certain pattern. Well, that data is fed into a program, and I can manufacture that part by way of computer. Then you have SIM, computer integrated manufacturing. And that basically refers to the combination of CAD and CAM. And it's a major step toward a fully automated factory. Presentation graphics, bringing lectures to life. Well, what is a presentation graphics software and what does it do? Well, basically, the software is to create a presentation, but it also helps to automate the creation of visual aids for lectures like PowerPoints, training sessions, sales demonstrations, and other presentations. Create slideshows directly on computer monitors or LCD projectors, including still images, animation, and video clips. Slides might include photographs, drawings, charts, and tables. Rule of thumb for making powerful presentations. Number one, know your audience. Always outline your ideas. Keep it simple. Use a consistent design. Don't clutter the screen. Keep each slide focused. Tell them what you're going to tell them, then tell them what you told them. That's how you make a powerful presentation. Dynamic media beyond the printed page. Modern media contains dynamic information that changes over time or in response to user input. Again, you have animation, desktop video, audio, hypertext, and hypermedia. Graphics and time, animation. Each frame of computer-based animation is a computer-drawn picture, and the computer displays those frames in rapid succession, 20. So instead of drawing each frame by hand, the animator can create keyframes and objects and use software to help fill in the gaps. Anything you can imagine can be done. If you can draw it, describe it. Excuse me for the cough. It's just a matter of cost. James Cameron, filmmaker. Desktop video, computers, film and TV, a digital or video digitizer can convert analog video signals from a television broadcast or videotape into digital data. Desktop video. We get into computers, film, and TV. Now, generally, we don't even use analog anymore, but analog is out there. So again, a video digitizer can convert analog video signals from a television broadcast or videotape into digital media. Here you have it on the screen. Now again, the slides. This is from Printers Hall. If you look at some of the images, they're 23 years old. We go all the way back to 2002. But because right now, I haven't seen a digitizer in a long time. I was doing computer-aided drafting. We use digitizers. But you have the video image captured by digitizing software. In this picture, a video camera, a video digitizer board. And here's what you got, the output. Basically, you have input and output. Also, video editing software such as Adobe Premiere makes it easy to eliminate extraneous footage, combine clips from multiple takes, splice together scenes, create specific effects, and other activities. Then you have morphs, are video clips in which one image metamorphoses into another. And then data compression. You have software and hardware which are used to squeeze data out of movies so they can be stored in smaller spaces. You see, even with computer graphics, you hear the word data come into play. Interactive media, eye, ear, hand, and mind. It's a combination of text, graphics, animation, video, music, voice, sound effects that allows the user to take an active part in the experience. Requires high quality color monitors, fast processors, large memory, CD-ROM drives, speakers, and sound cards. Now, you know we don't have CD-ROM drives on computers today. And you could see in this photo what they're talking about. They're going all the way back to DVDs. We don't even use DVDs too much anymore. Everything is downloaded now. Also, make mixed media. Multimedia authoring software glues together media captured and created with other applications. Multimedia authoring tools include pre-written behaviors attached to buttons, images, or other on-screen objects. We have visions of the future, positive aspects. Users become active participants. People gain control over the media and use it to create a new kind of digital democracy. Then there are negative aspects. Users become isolated and addicted to the technology. Media used to influence and control unwary citizens. Kind of have that now with a lot of the gamers. So overall, if you're going to major in computer graphics, you have a number of schools. I know the one I went to, it's in the Polytechnic Institute, Purdue. They have a good program. And if you get a degree in computer graphics, basically opens doors to diverse and dynamic career paths, primarily in the creative and technical fields. Common roles include graphic designer, 3D animator, visual effects artist, and user interface designer. More technical roles include software developer, computer systems analysis, game developer. You can use it for engineering, architecture as well, industrial design. But these are some common fields. Now, again, I just mentioned UI. Computer has a programming user interface. Also, you can create websites. You're a web designer utilizing computer graphics. Now, basically sum everything up. What you need to understand about computer graphics, it's the field focusing on creating, displaying, and manipulating images using computers and software. It encompasses the creation of both static and dynamic video content. Now, what do I mean by static and dynamic? If you don't know, when something is static, it doesn't move. If it's dynamic, it does move. Basically, what's included with static and dynamic visual content, it's 2D and 3D images, animations, and of course, more. So basically, computer graphics is essential in diverse fields like video games, movies, medical imaging, and of course, design. And why is computer graphics important? It's because they enable the creation, display, and manipulation of images on computers, which is a vital role for a wide range of applications across various industries. Now, from enhancing user interfaces and creating immersive virtual experiences to enabling scientific visualization, medical imaging, computer graphics have become indispensable in modern technology and daily life. And that concludes this program. Have any questions to ask me? Leave it in my comment section. Overall, computer graphics encompasses various fields. Again, I saw a movie, Jurassic World, that uses computer graphics. When I utilize Revit, or take a 2D image on Revit, expand it to a 3D image. You can also put different material from the graphics to make everything look real. Civil 3D is another one. Inventor, if you are on the mechanical side, Fusion 360. There's a lot of good software out there. Bottom line is you want to get in the field that is going to be interesting to you. See the background? That's all done by computer graphics. And what is this background? You might ask. Well, it looks like a circuit board of a computer with cooling fans. That's what it is. But if you understand rendering and rastering and how to draw everything in 3D, you can come up with prototypes. You come up with a design and scheduling. that's going to be good for your audience. Now, I will tell you this. In my field of civil engineering, we still use a lot of 2D. 3D is basically, in my humble opinion, it's a presentation software. I mean, you can put all the glitz and the glamour on it to make it realistic. But the bottom line, 2D is still out there. But if you want 3D, again, there's plenty of software that use 3D. And also, there's data. You got some other areas that use computer graphics and data and rastering, GIS, create maps, use Photoshop to create a map. You can use existing maps. You can clip maps, edit maps. There's so much you can do with computer graphics. That's why it is important to learn what computer graphics is and what it does. Because when you're watching television or a picture is taken, you're wondering, well, how do they edit an image? We can crop images, just like I said before. You can make images look like they've never been tampered. The beauty of computer graphics. But again, if you are interested in the computer graphics field, well, I already know Purdue University, Polytechnic, they have a good program, and there are other schools. Go to a community college, go to a major institution, and take a few classes. See how you like computer graphics. It is a good field, but it's a field that you have to be interested in, and not only have interest in it, understand what it is, understand what it does. Because computer graphics is just another form of technology that will not go away. And that concludes this topic on computer graphics. If you like what I just presented, comment, share, and subscribe. And if you're looking for some social and political content, check out my main channel, the 411 Talk Zone Radio Show channel. Here's where you can find me. The 411 Talk Zone Radio Show. You can find me on YouTube, X, formerly Twitter. You can also find me on Rumble and Truth Social. For this channel, the QCIS channel, you can find me right here on YouTube, X, formerly Twitter, and LinkedIn. And once again, thank you for viewing this content about computer graphics right here on a QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.